Let's evaluate the Laplace transform of cosine t. And of course, we might be using this for generalization of some similar situations having the expression of cosine. Now, we can use this formula for the Laplace transform. And with this, let's try to come up with the general form for cosine t. So integrating that here, this is equal to the integral from 0 to infinity of e to the power of negative st. Then your f of t is cosine t dt. The next thing here is, of course, to look for ways to integrate this. If you're going to talk about possibility of integrating by parts, by saying that you will have your u as your cosine t, to which you could get your du, and of course your dv in this case is e to the power of negative st dt. You can do that, and later on, part of your process as you solve for du, this will be moved to a sine. But from that, you will also need another integration by parts and returning to a cosine. It will just be alternatingly appearing. In short, we cannot use integration by parts here. Rather, we can use a specific formula in our calculus as we try to integrate a certain exponential function, in this case, alpha t, let's just call it alpha t, times cosine beta t for any value of a and alpha and beta. This is actually equal to an expression in this manner. E raised to alpha t. Let me move here because I believe the space will not be enough. E alpha t times alpha cosine of beta t plus beta sine of beta t all over, that's beta t. Let me again rewrite this for your own understanding, sine of beta t all over the square of alpha plus the square of beta. This is a formula in our integral calculus as we try to integrate the product of, this has dt rather. Okay, as we integrate a product of an exponential function and a trigonometric function where the integration by parts is no longer possible. So applying that here, automatically, simply plug in the values. Of course, here, the alpha, we know the alpha being the exponent of our e, except for t, so your alpha is negative s. In your beta is the coefficient of t, which is 1. So using the formula, the integral, no longer the integral, we will have e to the power of alpha, that's negative st, times alpha is negative s, cosine of beta, that's 1 t, plus beta, which is 1. I'm no longer write that, and sine of another beta 1 t all over the square of alpha, or in this case, the square of negative s plus the square of your beta, which is 1. So this will be equal to e to the power of negative st, negative s, cosine t plus sine t. Sorry, I forgot. This is integrated from 0 to infinity. Okay? All over s squared plus 1. Now, take note again, this is integrated by 0 to infinity. So let's try to substitute that. First, let me rewrite the first term here using the law of negative exponent, e to the power of positive st now. So again, let me have your negative s cosine t plus sine t all over s squared plus 1. So integrated from 0 to infinity. As we plug in infinity as this, or as t rather, as t approaches to infinity, sorry for that, my bad. Let me rewrite it. Approaches to infinity, this expression of 1 over e to the power of st will approach to 0 as this exponent will increase and increase and increase towards infinity. With that, by substituting infinity first, or looking at infinity, this first term will be 0, and no matter what the value of this, it will all be equal to 0. So that's the point here. Next is to substitute 0. So you have minus 1 over e to the power of s times 0, then negative s cosine of 0 plus sine of 0 all over s squared plus 1. Okay? This is negative 1 over 1. This is all over equal to 1, or we may no longer write that. So the negative of negative s, the cosine of 0 is 1, plus the sine of 0 is 0, all over s squared plus 1. So with that, double negative property, that's s, and of course, since this is 0, no need to distribute that, all over s squared plus 1. So this is actually the Laplace transform of cosine t. It's just s over s squared plus 1. In the next video, we will look into other examples where the beta is not equal to 1, and we may generalize all forms of cosine beta t. But in this case, for this question alone, we're able to solve the intended item equal to s over s squared plus 1. Thank you very much for watching.